So hello everyone. So this is Sisir to solve this problem. So this problem was given by me yesterday on my YouTube channel. If you haven't seen that, it's not a problem. You can just if you haven't seen this problem, you can just try this out right now. So rather I would say to pause the video and try this problem out first, and only after that you can play the video and look at the solution. So okay, so I hope that you have paused the video and you have tried this out. So let's go through the solution. So this solution needs some basic understandings of trigonometrical functions. So you might have studied about sines and cosines law, or you have studied about the Pythagorean theorem, which states that sine squared theta plus cos squared theta is equal to 1. So if you look at that formula and compare it with the first one, so which is sine squared x by 2 plus cos squared x by 2 is equal to 1. So you might be thinking how it came. So it came in the similar way as sine squared theta plus cos squared theta is equal to 1 came. So if you assume that theta is equal to x by 2, then you substitute in the place of theta, you substitute x by 2 and you'll get the term that is presented at the beginning of the formula. That's the most important formula that you will be needing to solve this problem. So the next formula demands a whole lot of basis on trigonometry. So it's a basic understanding of or a basic formula of double angle. So if you look at this formula, it says that cos 2x is equal to cos square x minus sin square x. Okay, so this is the formula to memorize. So the third formula is of integral calculus. So it states that there is an integral from 0 to some limit 1 by x squared plus a squared dx. So that will give you 1 by a arc of tangent of x by a plus c. What do I mean by arc of tangent? So arc of tangent is similar word to speak about for inverse of tangent. So if I ever say arc of tangent, then always make up in your mind that it's inverse of tangent. So let's go through. So now let's look at the equation once again. So if you look at the equation, it says that we need cos x term. So to get cos x terms, what do we get? What do we need to do? So we don't have any formula for cos x, but yeah, we have formula for cos x if we substitute or if we rearrange the value of cos square x by 2 plus sin square x by 2 is equal to 1. So after we rearrange, we'll get cos square x by 2 is equal to 1 minus sin square x by 2, or root under 1 minus sin square x by 2 by 2 will give you cos x, but that's a little complicated one. So let's go through a similar or a simple verification of cos x, or a simple equation of cos x. So if we go through the cos x term, I know for now that cos x is equal to cos square x by 2 minus sin square x by 2. Now you might be thinking how this is possible. Now I'll not leave this in this way. I will show you proof of it. So the proof declares not only the algebraic function but a type of a geometrical interpretation of this equation. So for now I'll not go for algebraic solution, but for now I'll go to the graphical solution or the graphical representation of y is equal to cos x and y is equal to cos square x by 2 minus sin square x by 2. So now let me make you familiar with the curve of cos 2x first, and after that I'll come with the graph of cos x. So let's look at the graph of cos 2x. So cos 2x is equal to cos square x minus sin square x. So let y is equal to cos 2x and let y is equal to cos square x minus sin square x. So you might be thinking that there must be two curves, but whilst looking at the screen right now, you can only see a single curve because the two equations are the same type. Their values must be same, or they must generate the similar graph pattern. In the same way, cos x must also generate the similar wave pattern. So you can see it here. So y is equal to cos x is equal to cos square x by 2 minus tan square x by 2. When I plotted that graph is represented in the black curve. So if you look closely at the black curve, you'll not see any differences between cos square x by 2 minus tan square x by 2. So you might be thinking this is not true, but if you want to try this out, you can try this out in um, any applications that you use, but also you can graph it by yourself. So if you look at the cos 2x graph, it's represented in blue curve. So after you do this, you are pretty much familiar that cos x is equal to cos square x by 2 minus sin square x by 2 just satisfies each other. So when it satisfies with each other, we have three formulas, but one formula has been manipulated. So formula that we have is sin square x by 2 plus cos square x by 2 is equal to 1, and cos x is equal to cos square x by 2 minus sin square x by 2, and everything is the same. So another thing, you have the integral calculus formula, so that's also important, so you have to memorize this one. So let's go through another one. Now let's solve this problem. So it's the time to solve. Woof, it took a lot of effort, right? But now it'll not take a lot of effort, so just substitute cos x as cos square x by 2 minus sin square x by 2 in the denominator part. So let's look at the denominator part. So in the denominator part, we have 5 plus 4 cos x. So can I write 5 times 1 plus 4 cos x, where 1 can be written as sin square x by 2 plus cos square x by 2, as I stated in the formula previously. And we know that cos x is equal to cos square x by 2 minus sin square x by 2. So we can substitute those values to get a simplified version of it. So after substitution and simplifying the whole term in the denominator, we get 1 by 9 cos square x by 2 plus sin square x by 2. So now there is a little problem out here. That problem we have to admit, and we have to assume, or we have to play with some tricks. So the trick goes in this way. So let's say if I divide numerator and denominator by cos square x by 2, I will get what? So I will get 6 square x by 2 by 9 plus tan square x by 2. So that's simple, right? Because 1 by cos square x by 2 is equal to 6 square x by 2, and sin square x by 2 by cos square x by 2 is equal to tan square x by 2. So that's simple. So now you have to use a popular method that is always used in integral calculus. So that rule is called u substitution. So substitute u is equal to tan x by 2 and take its derivative, means its derivative, the derivative of tan x by 2 gives you 1 by 6 square x by 2. So please follow the red line down the steps. You'll get rearrange the derivative curve. That means rearrange the value, or rearrange du by dx. So after rearranging, dx is equal to 2 by 6 square x by 2 du. We are going to solve this problem in an easy way now. This has also taken some tricks and some effort is there, but now it's simplified and it's a masterclass of solving a problem. Now it's the easiest steps that you can do. Now the easiest steps is to keep on the values, plug in the values of tan x by 2 is equal to u, and you will get this term. So after substituting each and every values, or after substituting dx as 2 by 6 square x by 2 du, 6 square x by 2 and 6 square x by 2 will cancel each other, and you will simply be left with integral of 0 to pi 2 du by 9 plus u squared. Now it's simple. You have du in terms of u. You have u in terms of du. Now you can simply integrate this. But now you need to use the third formula, which is also important in the integral calculus part. So the formula is, if you know the formula, you can pause the video and you can solve yourself. So I'll give you some few minutes. Okay, so I hope that you have paused the video and you have tried this out. So the formula goes in this way. The formula that I stated was 1 by x squared plus a squared dx is equal to 1 by a tan of inverse x by a plus c. So did you listen? I said tan of inverse, which is equivalent to arctangent of inverse. Arctangent, not inverse, okay? So it's arctangent of x by a plus c. So c is a constant. Now, replace a is equal to 3. Okay, so why a is equal to 3? We know that 3 squared is equal to 9. So if in the denominator we need a kind of a square term, we can place 3 squared is equal to 9. So we can place, in terms of 9, we can place 3 squared plus u squared. So x is equal to u and 3 is equal to 3 squared is equal to 9. So simply take the constant out, which is the constant is 2, and take the 2 out and you'll get the same particular equation that is shown above, which is always used in integral calculus. So you'll get 1 by a, which is 3, and tan of inverse of x by a, where x is u and a is 3. Now substitute u is equal to tan x by 2. Did you substitute that? Okay. After substituting that, now again use the interval to substitute the values of x. So at here you have to use the basic concept of integration. So when you find any area, so actually integration means to find area. So when you're finding area, you have to use the intervals to substitute or to get the exact amount of area that it occupies or a curve occupies. So when you replace the values of intervals with the intervals given in the question, so if you replace x is equal to pi and x is equal to 0, what do we get? So that's the key concept. So it's always similar in the integration part, that you always subtract from lower limit to the upper limit. So after you do that, you'll get tan pi by 2, because what I said is you have to substitute x as pi and x as 0. So when you substitute x at pi, you'll get tan pi by 2 by 3 and tan 0 by 3. So what do we know now? Right, tan 0 means 0, right? Tan 0 is equal to 0, and tan of inverse of 0 means 0. It's also 0, so this term will be cancelled out. So you'll see two arrows out there, so don't be confused that that is cancellation 1. So tan 0 by 3 is cancelled, means that is not equivalent, so that's cancelled, so it doesn't have any values. Let's go for 2 times 1 by 3 tan of inverse bracket tan bracket pi by 2 bracket closed by 3 and bracket closed. Now let's look at that term. So as we know that tan pi by 2 is equal to infinity, right? Tan 90 means infinity. Pi, basically it represents for 118 degrees. So pi is in radian right now, but if you look at the degrees, then you'll get pi is equal to 180. So tan 90 means infinity. And if you need to find the value of pi by 2, then pi by 2 is equal to tan of inverse of infinity. So if we replace in the main equation, which is 2 times 1 by 3 tan of inverse tan pi by 2 by 3, what do we get is tan pi by 2 is equal to infinity, means infinity by 3 will give you infinity, means tan of inverse infinity will give you pi by 2, which is given in the arrows. So you can just follow the arrow, not my instructions right now if you are confused. So you can know from there that tan of inverse of infinity is equal to pi by 2. So 2 cancels out and you'll be remained with pi by 3. So this is the value of this integral, which is integration of 0 to pi 1 by 5 plus 4 cos x dx is equal to pi by 3. So this is the value or the exact value of this integral. So if you got this value, congrats, you have done a good job. And if you have done it in another way, please show it in the comment section below. And if you haven't done this, then I guess you have learned something. And how to check this integration or this value? So yeah, as in my previous videos also I've stated that Wolfram Alpha is the most it's the most beautiful application to work out with. If you want to solve anything or if you want to solve any problems, you can just go through there and type your problem and it'll output the minimum value or the actual value that it pops out, right? So it popped out pi by 3. So that's the value that I got, pi by 3. And yeah, it was a long video, but I hope that you enjoyed.